Hello, Mr. Hulsey's class and the millions of people watching this video. This is Mr. Hulsey. I'm going to talk about geometric constraints today, and I'm going to primarily use Inventor to talk about them. So, when you come in after watching this video, you should take your new seat, which is based on the learning group, not the Automata project. Open up the 5.2 activity and create a new entry in your notebook called a 5.2 activity 5.2 geometric constraints. Here's the STEM news for today. This 18-year-old UT graduate at UNTang. Yes, you heard me right. 18-year-old UT. She graduated from UT when she was 18 years old, not into UT. She is now in the 30 under 30 list because she beat quantum computing. So that's really, really cool. She created an algorithm with classical computing, not quantum computing, that could prove how fast classical communication is. That there was a problem out there that was thought to be exclusive to quantum computing, but classical computing can do it just as fast, cheaper. So she kind of slowed the growth, or at least the need of quantum computing, but it's still very, very interesting. And she was incredibly influential just at 18 years old. Amazing. Vocab quiz is coming up the 29th and 30th. Take home and sign your blended classroom contract. Hopefully I will create those and give them to you on today is the 22nd while I'm making this video. The 23rd and 24th is when I want to give those to you, but we'll see. If you're confused about that, don't worry. Hopefully I will already have given it to you. Okay, today's agenda. We will talk a little bit about 5.1. We'll peer evaluate it a little bit. And then we'll have a short lecture with the traditional group. So again, flips people, please be quiet while we're doing that. And then we'll finish that activity for you guys. For the flips people, let's do at the end of class today. So here are the constraints that we're going to talk about. It's pretty easy. When you look at Inventor, there's 12 of them. And when you hover over them, there's a little tooltip, and that kind of explains what they are. So you don't need a whole lot of explanation from me. I'm just going to give you a couple of tips on how to explore this and how to do today's assignment. So there are three types of constraints: geometric, parametric, and assembly. Of course, Unit 5 being all about geometry, we're going to talk about the geometric constraints today. We already talked about the parametric constraints a little bit in the CAMS project. Hopefully you actually use the parametric constraints. That's when you use those formulas there to determine the sizes. Instead of just typing in 3 divided by 16 for your dimension, you can type in a parameter. So like whenever we made the CAMS, the nominal diameter was the parameter there. So we said D equals 1.5 or 2 or 2.75 or whatever your CAM nominal diameter was, and then we used that in lots of formulas. So one dimension would be D divided by 2 instead of just 1.5 divided by 2. That way it changes. So these constraints change as other things change, like the other diameters or other geometries. And then assembly constraints, we use those every time we create an assembly and put parts together. If I put my two hands together in an assembly and I say I want them to be touching, I would have to mate. That's a mate constraint. This hand with this hand, this face with this face right there. Actually, this is also mated together because these two planes, when I mate in an assembly, I'm just mating the planes. If I wanted them to snap like this, I would have to say this plane of this thumb with this plane, mate those together as well. So then it would go snap right up to there. But then, of course, I can still slide up and down, so I'd have to do one more. Maybe this plane of the bottom with this plane, snap, and then that's fully constrained how I want it right there. So assembly constraints is in 3 dimensions using multiple parts. Geometric constraints can be in assemblies or parts, and we'll see all the different kinds of things we can do. I would copy this slide down. These are the 12 names of the the geometric constraints. But again, the names are already on there and the tooltips are there, so you don't have to memorize it for use in Inventor, but you should memorize it for tests, and especially the big test at the end of course exam here. So the first one is coincident constraint. That's just joining 2 points together. Easy. You can see in this little example picture here, it's just joining the endpoints of those 2 lines onto the same thing. So I'm going to go ahead and demonstrate some of these, not all of them, but I just created a 2D sketch on the XY plane. Whenever you create some lines here, it gives you options. Watch, as I snap up to the horizon, I have this, you can see this icon pops up. Obviously you can't see me pointing at it, but this little icon here that looks like 2 horizontal lines, that's a horizontal constraint. So it gives me an option of putting a constraint in there, and you could see it right there before I closed out of it. And actually, if you right click and select Show All Constraints. This is big right here, F8, Show All Constraints. So you see this constraint here, that's a horizontal constraint. I can move this line around and it'll stay horizontal. I can move one of the points, but guess what? The other point comes with it. I can stretch it and skew it, but it remains horizontal. This one, I can grab one of the points and it'll move around. That point will move around and the geometry of my line will, but on this one, the dimension will change, but not the horizontal constraint there. So with a coincident constraint, here's my tooltip. Very beautiful example there. With my tooltip, if I wanted this endpoint to be on the origin, for instance, I could constrain that. And now, whenever I click and drag this, it won't stray from the origin. Even if I try to drag the line itself, it won't move from the origin. That's a coincident constraint. Number two, collinear. We'll make two lines on the same infinite line. Remember, these are line segments. Lines are infinite, so these two lines in this example are on the same line if you extend that forever. Number three, concentric. Con meaning the same, con meaning same, and centric meaning center. So two circles have the same center. So you click on the two circles, they'll have the same center despite the size relative to them. Fix constrains a point to a fixed location. If I wanted to fix this, maybe I could fix this point here. I can click on the point and then the constraint, and it'll fix on there. See, I can still, oh no, I think it constrained the entire, oh, nuts. Make sure you're not still in the constraint if you want to mess around. But yeah, there we go. I can change the length of it, and only that point is fixed. I can't move that point around anymore. And of course, we had a horizontal constraint, so I can delete that horizontal constraint. And that line, that point is still fixed, just like the origin is fixed. So I can fix any point. If I wanted to fix the second point there, you see how the whole thing is constrained. The whole line is constrained. It won't move anywhere because both points are fixed, rather. Number five, parallel constraint. Makes two lines parallel to each other. You have to have two lines, or you have to select two lines in order for this to work. I would always look down here where it says for help, press F1. When I'm using a tool, that gives me, that's the status bar. That gives me my directions. So select first line. Okay, I select one line. Select second line. And there we go. They're both purple because they're both fully constrained. This one actually can change the size of it because I haven't fixed that other point. But yeah, these two lines are parallel to each other. See, this constraint comes in a pair. Perpendicular constraint also comes in a pair. You have to choose two. Horizontal constraint is pretty simple. We've already talked about it a little bit. Every line can become, or a line can become horizontal, but it's pretty cool. The horizontal constraint can also work with two objects. Watch. A horizontal or a vertical constraint. See how that infinite line pops up on my center of a circle? I think it might pop up, yeah, on any point here. I can actually tell two objects to be on the same horizontal line. See, now they're on the same horizontal line. I can do that again here to here. So now they're all on the same horizontal line. Okay. So the same thing can work with vertical. You can constrain, that's what they did here. They can, on this one, they made the whole line horizontal. On this one, they made this point, and they made this point be on the same vertical line as the origin. In other words, on the y-axis there. Tangent constraint, we've already talked about. That makes lines smooth to circles. Lines smooth to circles. Tangent point is where a line is intersecting with a circle only on one point. See, right there, I made a tangent constraint there, but they don't touch because the line is infinite. The line is infinite. So I can move it around, and it's on that infinite line, but my line segment is finite. See, that's pretty interesting. And I made the line and the other circle are moving as I move this one because, remember, they have that horizontal constraint. So if I move all of this, everything else will follow in order for all the constraints to hold. Tangent. Smooth constraint I wouldn't really worry about. We don't use it. It's basically the same as the tangent constraint for our purposes. Symmetric is pretty cool though. Watch, I can make, let's see if this will work. I can make these two circles symmetric to each other across the y-axis. Here's a really cool thing to know, so I'd really pay attention here. Before I can create or before I can make these two circles symmetric around a y-axis, I need to make that y-axis interactable. So this is going to be very, very helpful in lots of circumstances. Here's my y-axis, but I can't interact with it. I can't put a point there until I project the geometry. Project geometry means take geometries or shapes from other sketches or from the origin and insert them into our sketch. So now that line is, that y-axis is inside my sketch. Let's see, my status bar says select first sketch element, select second sketch element, okay, and select the symmetry line right here. Now those two are symmetric to each other. Whoops, that was too big. That's not what I wanted to do. But if I were to change, oh mercy, I've got too many constraints in here. That's why it's going wild. If I wanted to, here we go, move this up and down, I could do that. If I wanted to change the size, because I've got that tangent constraint still over there. I've got these two sketches symmetric to each other. Very simple. Equal constraint means they've got to be equal in size. Symmetric, I think, includes the equal constraint. Let's try it with these two lines here. This one and this one. Yep, now they are equal in size, and I can't any longer change that. The length of that line. Equal in size, shapes or lines. Knowledge check. Of the pictures, of the constraints pictured on the right, what is number 3 called? What is this one called? Yes, it's called concentric, same center. Knowledge check again. The rectangle tool automatically applies some constraints. 4 constraints to a set of 4 lines. And I should say, 2 of them are repeated. So there are only 3 individual constraints. So what are those three unique constraints? Okay, so the parallel constraint is one of them. Parallel constraint here and here. I'm sorry, here and here. These 2 lines are parallel, and here, those 2 lines are parallel. So that's the one that's repeated. I also have a horizontal constraint, and as long as this one's horizontal, this one's parallel. So that one is horizontal by default. And then these 2 are parallel to each other. But now I've got the 3rd one and the final one. A perpendicular constraint. That fully defines a rectangle. Another knowledge check. What class of shapes could I make if I removed this perpendicular constraint? So no longer does it have to be perpendicular, but I can move it around. I'll give you a sec. Okay, to answer this one, I'll actually go do it in Inventor. Let me just zoom down over here so we can see what's going on. Here's a rectangle. I've got all my constraints showing. Show all constraints. Now I've got all my constraints showing. And if I try to move any of these lines, it stays a rectangle. If I try to move any of these points, it stays a rectangle because I have a perpendicular constraint. I've got points. There we go. If I try to move any of these points, it stays a rectangle. But now if I delete this perpendicular constraint, now if I try to change it, move any of these points, click on the point, click on the point. Let's click on this point down here. If I click on any of these points, there we go. I still have my parallel constraints being met, and this horizontal constraint here being met. But now I can change this so that it's no longer rectangle. I don't have 90 degrees. I have other angles. Now I have parallelograms. So the answer is parallelogram. Okay, the last thing I wanted to talk about real quick is work features. We've already briefly went over those some in the CAMS project. But we've got work points, work axes, and work planes. Those are going to be very, very helpful whenever you want to sketch on an interesting new surface, or if you wanted to sketch sort of in 3D. So on an object like this, I'm not going to go over the whole rest of this PowerPoint, but on an object like this, when you have a cylinder, you can't sketch on a curved surface. You can't sketch on a curved surface. You have to create a work plane. You have to create a work plane. So let me try to, let's see, just delete all of this. I want to create a circle, but again, I just deleted my center point, so I've got to project it back onto the sketch. Circle, I'm going to make a circle, and then I'm going to real quickly extrude it. Just, I don't care that much. Now, again, I cannot sketch on this curved surface. I can sketch on this surface because it's not curved. It's round, but it's not a curved surface. It's a flat surface. So in order to sketch on something like that, I need to create a work plane. Here's what I can do. Tangent to any of these would work, but I like this one. Tangent to surface and parallel to plane. What's the surface? The curved surface that I want. parallel to a plane. It doesn't matter, I'm just demonstrating, but definitely one of these. Not this, because that won't be tangent, but one of these. Let's try this one, and there we go. Now we've got a sketch right there. If I wanted to add, something, whatever kind of shape, just blah, 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 right there. And then extrude that, I can, however I wanted to. You'll notice, though, that it doesn't quite meet up. See, there are some gaps right there. So you might have to share the sketch and then extrude it backwards into the curved surface just to make it look good. Here, I'll do that real quick. Share the sketch. Now, using that sketch, we can extrude it again. We can extrude it backwards. And then I'm just going to say 2 next, and that fills in those gaps. 2 next, that fills in those gaps. See, you can kind of sketch on a curved surface this way, but you can't sketch on a curved surface. You can only sketch on work planes. Okay, and that's about it. There are lots of other reasons why you need work planes, and then there are lots of ways to create them for whatever your purpose is. But that's all I'm going to mention today. Just remember these constraints here. Make sure they're in your notebook. And that's it. We'll do an activity, and I'll explain that when you get here. Thanks a lot. Have a good one.